Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Matt Weagle, who is currently an engineering manager at Lyft. Matt Weagle, welcome to Maintainable.
Oh, thanks, Robby. It's great to be here. Thanks for having me.
Yeah. If someone were to ask you if a software code base was maintainable, what character traits would you think of to kind of help answer that sort of question?
That's a good question. I think that has a lot of dimensions to how I might look at it. For me, it's really more goal-based. So it's sort of what properties does the code base have to have such that the team can effectively make forward progress and doesn't suffer from some of those technical debt things that are inevitable when you have code bases. You know, at a certain scale, there's always going to be parts of code that don't work well in the environment, either because the environment's changed, the business has changed, capabilities have changed, platforming has changed, and that's just sort of the one constant is that things change. So in terms of specific character traits, integration tests, unit tests, documentation is usually helpful, but often at a conceptual level, sort of what does each module do? And that leads into layering, decoupling. Protocols are good because they help create nice failure domains and more trust boundaries. So things like all data is untrustworthy until proven otherwise. And in general, assuming that the people on your team that were responsible for some of that code all had good intent, and it's not necessarily a single person's decision that gave rise to code right now that perhaps is suboptimal in the environment. Given that you're there, how do we evolve it to somewhere else? And that might be a series of steps, but realizing you want things that are maintainable, sustainable, work well in operations, don't create operational debt because that can easily overwhelm the code itself. So as I said, it's sort of a rambling answer, and I think that's because sustainability means a lot of different things, but ultimately it's about, for me, how do we make forward progress given that we've made previous commitments?
You know, you talked a little bit about protocols and failure domains. Can you touch on that a little bit more?
Yeah. So one of the things that's, when you have these, if you've seen like the Death Star topologies of microservices where, microservices call A to B to C, and then somewhere there's a double Z, and that's very frustrating. And so when you have those failures at a distance, because you haven't sort of had an opportunity to enforce, if something fails, it's going to fail within this bounds, and that failure won't allow leak and cascade. It's those cascading failures, garbage in, garbage out kind of thing that can be very challenging to debug. Also because the team that may be responsible for service B, you might know, but the team that's double Z, you probably don't know. And they really have no idea why their service is currently failing. And it's because there's sort of that implicit level of trust, which is really easy to grant, even within an organization. And out of no ill will of any given person, a commit may come in, you may change a proto, someone may change a field and a message, and that can create a whole kinds of cascading failures. And so the more you can kind of keep those failure domains scoped, you might have heard this, like the bulkhead pattern from Michael Nygaard's book, keep those scoped and then layer services on top of them that know how to deal with failures. All those components are all going to fail. And that's not a value judgment. It's just more like they'll produce undesirable behavior. So how do you build that supervision to get recovery built in?
Interesting. And, when you talk about protocols again, in terms of just how different pieces are working together, and how does that translate over into the human end, where I think you touched a little bit about different teams are interacting with different parts of this overall system. What sort of approaches have you seen work well to kind of keep communication open on that level?
Yeah, so the protocols are helpful because they help formalize the expectations. They can be used in a defensive way, and that's not really constructive. What they're really meant to do is limit the surface area that gets propagated. So what I've seen be effective are things like protobufs, JSON schema, if you're going to use thrift, some formal definition of sort of what your service expects and what you can validate, and then being extremely constructive if something comes in that doesn't meet that. And really, that's a way for both teams or all the teams to surface their implicit expectations of what they need, what state they need passed along. And it can really help facilitate that shared understanding of, our services need to communicate this kinds of state. What's the minimum amount of state we need to provide? And then how can we actually enforce that? Because as the components evolve, we want to make sure that that contract is solid over time. So it gives teams the freedom to innovate, but those interfaces remain those invariants in the system and prevent cascading failures, which are not fun, inevitably happen at 3 a.m., no matter what time zone you're in. That level of explicit agreement seems like it's a bit of work up front rather than say, hey, I'll just throw you some JSON. But over the long haul, that can really pay off and really make it and more constructive for everybody to figure out where, when something goes wrong, where to start diagnosing.
That's interesting. And you touched on just that doing some of that upfront work, and how does that? I'm assuming there's times when you're working on outlining, say, your contract or what your schema or your JSON, your API, or some. I'm trying to think of a tangible example there where two teams or multiple teams are needing to collaborate at the same time on building their pieces, but that's not been formalized yet. What sort of process have you seen work well, or do you feel like it's better for some teams to maybe hold off on doing some of their work until the API team has figured out what they're working on, so that there's kind of like this? How have you seen that work well? Because I've seen a lot of the problems where you get multiple teams working together and they're like, well, it's not like you're making changes to something in an agile fashion, and then all of a sudden it's like a couple sprints into it, and like the teams are not synced at the same time, and that becomes problematic.
Yeah. The integration costs are the ones that are the balloon payments that come due at the wrong time. So one of the things that you can take advantage of with APIs is actually media types, right? You can say, instead of saying application like JSON, you can have a sub media type that's the schema, and you can actually define that. So you might see that in like API Gateway, and Amazon has JSON schema enforcement. And you can put that kind of thing in your edge as well to say, look, I'll syntactically verify JSON and semantically verify some media type. And so the way to do that organizationally is to work on examples. So start with an example, like what JSON do we need to pass around? And then kind of have those two teams iterate together. And then once that's tentatively agreed to, all right, how do we promote that to a schema? And so how do we aim towards that? And then have each team work independently, knowing that that's going to be the contract. So the team that's going to be the producer might just generate a mock generator. Just look, here's the endpoint. We're going to give you some gobbledygook, but it's going to meet the schema so you can start iterating. So you can always have that in tandem development, assuming your teams are kind of siloed by deliverable rather than by goal. And that's very common for front end, back end teams. Backfill the implementation. So do all the heavy lifting. And then when it works, get rid of the proxy or the mock implementation, turn on the real one. And there's no deferred integration costs between the two teams because they've already been coding to the same standard. The nice benefit of doing something like that is if the producer who's adhering to the schema is generating valid data, they can generate all kinds of crazy data that might actually chaos monkey test the consumer. And so that you get kind of this bonus of, that's a URL, please don't treat it as a string. So you can get some nice bonuses there and allow teams to do work independently. Getting people in the same room or virtual room, ironing out an example, getting into a schema, getting that contract, those integration points hooked up, and then backfilling the deep work to get that to actually be reality.
That's really great. Thanks for diving into some more tangible examples there. I'm thinking a little bit about what sort of processes have you put in place to make sure that, I'm assuming your teams are always thinking about, oh, this is introducing some technical debt, or we know that there's that issue over there we haven't touched in a couple of years. Like on a day-to-day level, what sort of ways do you see your teams talking about technical debt and then also translating that into a task for someone or for a team to take care of at some point?
I sort of have a technical debt triage in the back of my head. And so my triage rules are production, then staging, then me. And production because it impacts customers, staging because it impacts the team, and then my stuff because it impacts my feature. Technical debt shows up across the board. As soon as you have code, you have commitments, and you have debt. We all kind of have debt in some part of our life, because we're doing something valuable. So it's really about what level of that support now is so large that it's preventing us from maintaining flow to develop new features. So the number one thing for me is if there is alert fatigue or there is sort of just a general malaise about the ability to improve the product and we're always responding to alerts, that disrupts all kind of development flow. It's extremely exhausting, extremely stress creating. That's the number one thing we tackle. So how do we actually get the service to a point where it's operationally sustainable? So we have kind of a known load of failure cases. And then we'll talk about, well, do we have debt in terms of, are we scheduling too many machines? Is it too expensive? Is the latency too high? Is it too hard to refactor? Those kinds of broader architectural things, they'll end up being longer term discussions. Like, hey, we actually want to move away from REST into gRPC. That's probably going to be a multi-stage process. So let's get together. Let's figure out at the end, when we're all done, what characteristics do we want? And then let's work backwards to figure out how we can gradually refactor over time to end up at that point. Those stop the world, we'll be back in 6 months after we're done rewriting. I've had a hard time getting that time, but it's easy to find time to say, all right, here's a small module. Can we prefactor it knowing that we're going to go somewhere else? Can we make it more declarative? Can we make it more configurable? Can we make fewer assumptions about its environment? Is there a way we can make it so that more developers can concurrently work on it? So how do we do these gradual pre-factorings, knowing that at the end, there probably will be that disruptive jump, but make that jump as small as possible?
Yeah, I wanted to touch on something you said a couple of moments ago. You're looking at these problems, you try to change the conversation to being what characteristics or like an ideal future are we looking to have in terms of how we manage this part of the code base or operationally, and how disruptive, you also touched on like alert fatigue and stuff, like having you and your team just talking about like, it'd be nice to have an API where we're not dealing with these sorts of regular problems. And
yeah, so there's specific things. So if we're having problems where we're DDoSing our database because we have a fan out workflow that's crushing a database, it creates cascading failures that are hard to manage. So that's symptomatic of a pattern that we want to improve. So let's identify what that pattern is. A pooling pattern, we're going to have a service that wraps the database. We're going to basically offload that. That's a pattern that we're then going to roll back into the database or into the service. So let's identify this failure case that's generating the alerts. Let's see if that's representative of a kind of architectural pattern that we want. And then let's move to that. So that might be, say, DDoSing a database because you have a high fan-out workflow and you're spinning up, thousands of Docker containers that are all pigpiling on your database or whatever. So that's one. Another one might be, hey, it's really hard for us to diagnose errors. Like, okay, why? Well, our errors are spewed across Kibana. So that takes a lot of time to debug because we don't have a consolidated error message. All right. So that's symptomatic of the software not being self-aware of its own requirements. All right. So what we want to do is say, I want one log statement that has preconditions, detected state, failure mode, and behavior. And I only want to have one URL basically. So if I could have one URL that told me everything, how would we make that happen? And then how do we roll that thing into the software so the next time there's an error, we have the same expectation? So it's like building those kind of fundamental patterns and then rolling them back in the code base to help gradually pay down technical debt in a structured way, as opposed to one-off. Like, oh, well, we're DDoSing the database, so why don't we just, we'll do that one time. It's like, it's probably symptomatic of larger things. So let's figure out what those are. Let's formalize those and let's pull those back in and pull other parts of the code base up to converge on that, because then we can reuse the code we wrote.
That's great. So what types of tools have your teams kind of leaned on over the years to help you identify areas of problem within your software code base?
That's a good question. Whiteboards. I think, there's some things like cyclomatic complexity. There's some things where we might do static code analysis. Realistically, the architectural things are driven by experience and people having conversations. I haven't found a tool like I've seen way back in the day where Eclipse would say, refactor this into some giant thing. I have trust problems with IDEs, I'm not going to lie. I would prefer to do it manually. And a lot of times those are just, they're porcelain level changes. I mean, they'll refactor things that the IDE understands, but they're not going to do the architectural pattern changes. Those are really just, look, let's go get in a room, let's get a whiteboard. Let's talk about let's be open. And as a lead or a manager, creating a space where people feel comfortable disclosing that kind of honesty. Because if people aren't honest about, hey, the service, we can make it work, but it's not really where it needs to be, they're pounced on as an opportunity because, well, why is it like that already? Then they're not going to be open about sharing in the future. How do I create an environment where things are open? Because things are always breaking. It's just the way the world works. Find the specific things, up-level the conversation, have people say, well, what has worked better in the past, right? Maybe we change maybe our database isn't denormalized properly. Maybe we should use a key value store. Maybe we should use an event source. Maybe we should use a different pattern because we're not going to necessarily get away from this one problem. And then letting people talk. Say, all right, let's come up with a plan and let's figure out how to get it done.
Do you think with all the third-party software tooling that we have available, do you feel like it's less complicated to manage the long-term maintainability software now than it was, say, 15 to 20 years ago?
It's different, which is a very unsatisfying thing to say. They're different but similar. I've worked on large C++ code bases. Those have their own maintainability challenges. Compiler warnings are their own special kind of fun afternoon. But that's a different kind of maintainability issue, but the similar kinds of conversations, just with slightly different words. Because if fundamentally you end up pooling the same kind of resources, just so happens they're local, or you need to actually be considerate of the file system instead of Dynamo. But I think that in general, I understand the value of things like service meshes and things like that to offload some of this to applications. And I think there's a huge value there. But fundamentally, me as a service provider, I'm responsible for what our customers consume. So I kind of need to know more than might actually be in my code base. And that puts a different kind of burden on me. So it's before I might not need to know about some library, but now I actually need to know Istio is doing this and Kubernetes is doing this. And we actually have to manage our Docker images. So it's sort of more broad, I guess, across technologies rather than broad across a large code base.
You touched a little while ago about having the time to do like any bigger rewrites. Have you historically been involved in many large rewrites, previous positions?
Yeah, I have done a couple. They are, I think the euphemism is challenging. So I did one where a team had been a victim of its own success. And that's often where a lot of rewrites are needed. They reach those inflection points for scalability, and they just need to fundamentally change things, right? Twitter used to be Ruby, and that's not going to scale for what Twitter's use pattern actually is. One that I did was a schema basically was putting a lot of pressure on the backend store. The backend store, in fact, responded to that level of pressure by internally segfaulting and crashing the entire cluster of nodes.
Oh, awesome.
Yeah. And the nice thing about that is it actually wrote it to the op log and replicated so the entire cluster would go down within a couple seconds. We're not going to name names. There wasn't a gradual way out of that. We effectively had to rewrite the application to get away from that access pattern to offload pressure from the back end. And that was a long, long process. Because as you can imagine, the assumptions about data retrieval and relationships are everywhere in the code. Everyone on the team was extremely capable, but it was just, they were so successful that the assumptions they made were no longer valid. And that's a lot of times when I've worked on things is just, hey, this is great. And the way I look at that is now we have an opportunity to step back and figure out what we learned and then do something a little different, knowing that this is our new usage pattern. Those kinds of projects are hard because they can be very demoralizing because there's not a lot of progress along the way. You're doing all this work below the waterline. A lot of it is frustrating work because you also have to be sensitive to how are we going to do a graceful promotion? How are we going to do parallel writes? How are we actually going to know that the two implementations are equal? So that's months and months of work, literally, for a team of anywhere from 4 to 8, but there's no customer impact. It can be hard to maintain team morale and momentum because you feel like you're doing all this work and it's really technically interesting, but you're not providing new value. You're not doing things with lower latency. You're just sort of trying to keep the lights on.
Right. I bet. Given that you've been in a management role with engineering teams for a number of years, what would you say is some of the most common mistakes that you see when software developers approach legacy code bases?
Assuming that the person who wrote it didn't know what they were doing, making assumptions about the intent of the author rather than the broader context for why it might look a certain way or what has changed from the time it was written. And it's very easy to kind of throw around the term like developer did this. It's like, well, probably it was a designer and a product developer and there was a manager and then there was some deadline and a lot of things conspired to create the artifact you're looking at now. Assume good intentions of the people that were there and realize that the world changes. And so maybe the code doesn't do what you want it to do anymore, or it's not as efficient, or it doesn't use a technology, often because that technology didn't exist at the time the code was written. And then saying, all right, we're here now. What do we need to do to get somewhere better? And focusing on the goal rather than the capability or the intent or the awareness of the person that created the code. Because I don't know about you, but I look at the code I wrote 6 months ago and I'm like, wow, I don't know who wrote that. I'm not sure what that person was doing. And that happens quite a bit. I try to be aware of the constraints that people did things in the past and focus on where do we want to go and how are we going to get there.
Right. I think it's like a level of introducing some empathy into the people that previously worked on the project or the code base that you're now interfacing with. And if they hadn't done that work and it didn't get to where it would, you wouldn't have that job maybe working on that. I think there's a lot of assumptions made. My company specializes in basically taking over existing code bases. That's what we focus on. And so there's a lot of conversations about like internal workshops on it. How do we even talk about previous developers on projects that we worked on? Because it is really easy to go down this path. Like, what the hell are they thinking? And it's just, what are they going to say about us? It's like, let's be mindful of that and know that there's constraints. And sometimes the skill set might have not have been where you are today. And that's not their fault. They were doing hopefully the best that they could with the given resources and constraints that they had at the time. And how do we make it better and move forward? So it's always interesting how different teams approach that. So I think that was good that you're kind of focused on that. I think that's been in my experience as well.
Yeah, I think that's a great way to phrase it. I always try to be self-aware, and I think empathy is the right way to put it. So in the future, what am I going to think about what I'm doing now? And how can I be gracious and empathetic about that?
I think it can also be a little too easy to talk about previous developers because they're not in the room anymore.
But it's even worse when they are in the room and someone hasn't looked at the Git log.
Yeah. And they're like, oh, that was me.
Or it was the other person. It's all a provisional enterprise, realizing that it's always being constructed and always being changed rather than this PR is the end of this entire line of thought and will never be changed, right? And so when you kind of, if you look at things as immutable in one time rather than an ongoing process of evolution, it's easy to kind of fall into the trap of not having enough empathy for the people that came before you, which could be yourself.
Yeah. Have you noticed that there any distinction between, say, someone's seniority as an engineer, say, the difference between junior, mid, and senior level developers and how they talk about legacy code and technical debt? Do you feel like there's any correlation there?
I don't know if it's statistically significant, but I have seen individuals that exhibit each one of those phases. And I think senior is just, you've made enough mistakes that you've come out on the other side. That's not necessarily tied to seniority, but maybe it's just tied to learning rate and there's all kinds of things. But yeah, I have seen those kinds of phases of the known knowns and the known unknowns and kind of where you are and how, as you said, empathetic you are to everyone at different points in time.
You touched on learning rate there. Can you elaborate a little bit more?
Being able to reflect, not necessarily abstract notion of what it means to be smart, but it's sort of like, I would echo the air quotes around smart, being a little bit more self-aware about what went into this decision, what were the constraints, what was I thinking at the time, what was my mental model of the system, stepping back and using some metacognition about, well, why did I choose to implement it like this? Are there things that I can do in the future at a meta level that'll prevent me from making those same kinds of mistakes? That's sort of about being humble enough to be like, yeah, I know enough to be here. I could probably learn some things. So what didn't go so well? And what kinds of things can I do differently in the future? There's a great paper about, on the morning paper a little while ago, about somebody who wrote a mail server. And it was about writing secure software is all about finding those meta patterns and using them over and over and over again, because they'll guide you in the right way. And that's someone who's eminently qualified, but still humble and self-aware enough to sort of say, yeah, that I could have done that better. How willing am I to incorporate that next time around? And the fact that I didn't do it before doesn't mean I'm a bad person. It might just mean I didn't have an opportunity to learn it. You know, it's not a metric, more like a philosophy of being open to evolving and changing.
I'll be back with my interview with Matt Weagle in just a moment. Hi, it's me, Robby. I wanted to thank you for listening to the Maintainable Software Podcast. If you're finding these conversations remotely valuable, please consider sharing it amongst your peers and or writing a review on Apple Podcasts to help spread the word. Thanks. So let's imagine that there's a few developers, I hope, listening to this podcast, this episode. They're at a job somewhere and they feel like their concerns about the long-term maintainability of the software aren't being heard by, say, the product owners or managers, but they want to start improving some aspects of the code base. They might be worried about asking again because they keep hearing not yet or not right now a few too many times, and they're maybe thinking it's not worth asking anymore. What advice might you offer them today on how they can take some action going forward productively?
I vicariously feel all of those developers' pain. Try to phrase those requests, which are perfectly reasonable in the context of what it will enable the team to do in the future. So lateral moves that offer perceived, that are based sort of on a technology, a pure technology play. Just as a hypothetical example, you know, we used to deploy VMs and now we want to deploy Docker. Those are, in some sense, if you ignore the security for a minute, logically equivalent. What is that going to do for the team? Now you could phrase that in terms of it'll mean higher utilization and lower costs. Maybe it means better orchestration. Maybe it means more visibility because you can put a sidecar mesh on it, which will reduce your ops load, which means you're freed up to do more feature work. So phrase it in terms of what does it mean for our team in the future rather than pure technology. Hey, this is cool. I think we should use this. Jessica Kerr has this thing about the taxonomy of yak shaving. As you get lower and lower, things like, oh, we want to change the way our team codes. I want to use Rust because it's more performant. That in the abstract may be true, but perhaps everyone in your team already knows Python. There's a theoretical benefit that Rust might provide these sustainability, but in the context of your team, that's going to be an uphill battle. So maybe if you do things like, hey, our team uses Python, but there's some static analysis tools like Vultr or PEP standards that we can apply that'll help up-level us, do it in the context of where you are and what that will enable downstream rather than just we should use a key value store because they're cool.
Yeah, that's really great. So when developers, sometimes when they raise things, it sometimes usually comes from a source of like, this has become very problematic or this has been a stress point for us. But to frame that around, this is going to allow us to do X, Y, or Z. It's going to speed up our velocity in future sprints or whatever have you. And we're going to get more out of the team for this, or we're all going to level up a bit more. And so we're going to have more confidence in what we're doing or improve the test suite or what. I think it just always, there's a lack of sometimes the extra few little questions you need to answer to kind of help sell the idea. Because I found that it's rare that companies say, no, I don't want my product to be better. I don't want more quality in my product. It's that they're never asking for it. They're like, they kind of expect developers to take care of this stuff for them and to be an advocate for themselves as well. But just that simple step of, I wouldn't say it's simple because you have to actually like think a little bit harder about like what's the underlying benefit from going down this path. And so I think you touched on a lot of good ideas there.
Yeah, and then just to follow, if there's a way to make that measurable, if you can make that a metric, and that doesn't mean if you can do SLO, SLAs, and SLIs, then that's great. But even if you just have a Grafana chart or something like that, say, look, we lost 40 person hours last month dealing with alerts. That's effectively one person's week. So what does that mean for velocity? How do we drive that to zero, right? And Charity Majors at Honeycomb talks about this. If you're running a service on call, one of your metrics is how many times people responded to things out of normal working hours. Mm-hmm. And as management, drive that to zero. And if you can at least surface that, you can make that loss visible to management and help rally around, hey, let's drive this in the right direction because it'll unlock exactly the things you mentioned.
So with that, I want to kind of wrap up, but a couple quick questions. What books do you find yourself recommending to software developers most often?
I recommend everybody read Camille Fournier's A Manager's Path. That is a great book. Whether you're an IC or whether you're a C-suite person, it gives a great overview on terms of each level in your company, kind of what they're responsible for and the way they see the world, which can help conversations go a little bit better. There's a lot. Release It. It's a great book. The Phoenix Project. I just finished Inmates Are Running the Asylum by Alan Cooper, who worked on Visual Basic, and it's about sort of goal-driven design. And a lot of these things are about goals. So how do we change the conversation from inputs to outputs? What is the goal we want? Those are books that I recommend a lot, and I probably have more, but. No,
that's great. I hadn't heard of The Manager's Path yet. I'm going to have to check that one out. And where can people learn more about you online?
I'm at Weagle, MWEAGLE at Twitter, and that's a great place to get started.
Excellent. Well, it's been such a delight having you on Maintainable, Matt. Thank you so much for joining us.
Thanks so much for having me, Robby. It's great to meet you.
Maintainable.